Good morning, students. This is the question of indefinite integration that is asked in IIT 2019 means 12th April. Question is that let alpha belongs to 0 to pi by 2. It is the interval where alpha belongs be fixed if the integration of 10x plus 10 alpha upon 10x minus 10 alpha into dx equals to a of x into cos 2 alpha plus b of x into sin 2 alpha plus c, where c is a constant of integration. Then the functions a of x and b of x are respectively. Now we are going to solve this question. Please see how can we solve it. Integration of 10x plus 10 alpha. Firstly, we will break 10 in term of sin and cos. So 10x means sin x upon cos x. Sin x upon cos x plus 10 alpha means sin alpha upon cos alpha, because the formula of tan theta is sin theta upon cos theta. And in the denominator what is given? 10x. So we will break sin x upon cos x minus sin alpha upon cos alpha. There is no need to write here RHS because we have to find out the a of x and b of x and into dx. So it is clear that what is the LCM of cos x and cos alpha? LCM of cos x and cos alpha is cos x into cos alpha. Cos x into cos alpha both are cancelled here. Now multiply sin x into cos alpha. Sin x into cos alpha plus sin alpha into cos x. And in the denominator, sin x into cos alpha minus sin alpha into cos x. We will not write cos x into cos alpha because cos x into cos alpha is cancelled here. Now what is the formula here? Sin a into cos b plus cos a into sin b. Sin a into cos b, here angle A is x and angle b is alpha. Angle A is x and angle b is alpha. This is the formula of sin a plus b. So it is written as sin x plus alpha, because formula of sin a plus b is that sin a into cos b plus cos a into sin b. And what is the formula? In the denominator, sin a into cos b minus cos a into sin b. Here angle A is x and angle b is alpha. So this formula becomes sin a minus b, x minus alpha into dx. Now integrate. Put x minus alpha equal to t. Put x minus alpha equal to t. Now differentiate. Now differentiate with respect to x. Differentiate of x with respect to x is 1 and derivative of alpha is 0 because alpha is a constant here. And derivative of t with respect to x is that dt by dx. So this becomes dx equal to dt. And here we find the value of x in terms of t. So this is x equal to t plus alpha, because alpha goes to the RHS. Now putting these values, integration of sin x plus alpha, that is the sin t plus alpha, put the value of x plus alpha, and in the denominator sin value of x minus alpha is t, that is the sin t, and dx change to dt. Now here we can see this becomes sin t plus 2 alpha upon sin t into dt. Now applying the formula sin a plus b here, so this becomes sin a into cos b, that is the sin t into cos 2 alpha, sin a into cos b plus cos a into sin b, that is the cos t into sin 2 alpha. This is the formula of sin a plus b upon sin t into dt, sin t into dt. So dividing sin t separately to each terms, that is the sin t and sin t both are cancelled here. Cos 2 alpha is constant, cos 2 alpha goes outside, and integration of dt plus sin 2 alpha is constant here, sin 2 alpha goes outside, and cos t by sin t is that the cot t. This is the formula of cot into dt. Now cos 2 alpha and integration of dt is t plus sin 2 alpha and integration of cot t is log sin t plus c. Putting the value of t is that x minus alpha. So this becomes cos 2 alpha into value of t is that x minus alpha plus sin 2 alpha into log sin t, that is the value of t is that x minus alpha plus constant. Now we see in the question we have to find out the value of a of x and b of x, and in the RHS it is given that a of x into cos 2 alpha plus b of x into sin 2 alpha plus c. On comparing both sides, we see here that cos 2 alpha into cos 2 alpha same is here. So value of a of x is that x minus alpha, and value of b of x is that sin 2 alpha. Sin 2 alpha is common here. Remaining part is the value of b of x, that is the log sin x minus alpha. This is the answer of this question. You can also take a screenshot of this question